Plastic tubing is used everywhere: cars, hospitals, homes, and more. In this video, we'll look at how clear, flexible PVC tubing is made with a special focus on tooling. The process begins in the extruder, where plastic pellets are melted and conveyed under pressure and heat before being forced through the die. Right after the clamp comes the hot tooling, which shapes the molten plastic into a tube. Then the cold tooling takes over, sizing and stabilizing it before cooling. There are many types of tooling available, but the ones shown here are designed specifically for the size and material being produced. Hot tooling, where the molten PVC begins to take shape. It's made up of two main parts: the die or ring, which sets the outer diameter, and the pin or mandrel, which forms the inner diameter. The pin also has a small hole that allows air to enter the tube. This air can be left open to atmosphere or supplied under pressure. The spider holds the pin in place while allowing molten material to flow evenly around the air channel, forming the hollow tube. When pressurized, it may give more control of the inner diameter, especially important in applications like medical or automotive tubing. The die and pin shape the hollow tube and regulate plastic flow. Even slight misalignment can lead to uneven wall thickness, surface defects, and loss of dimensional accuracy. Next comes the cold tooling stage, or in this case, contactless tooling, where the oversized tool creates a gap that allows water to surround the extrusion and cool it evenly. It includes several key parts: the entry cone, tooling holder, followed by the sizing plate, the water well, diffuser, and calibrator. Together, these elements size and stabilize the tube just before it reaches the cooling tank. If the fit here is too tight, the product can stick, tear, or show stress lines. Too loose and dimensions drift, ovality increases, and stability is lost. Even small misalignments can lead to warping and uneven cooling. Getting this stage right keeps the tubing round, consistent, and without the stress lines shown here. The entry cone is critical. It leaves a small gap between itself and the sizing plate, forming a thin water layer that skins the product and prevents surface contact, controlled by the first valve. The vacuum section applies negative pressure, and if air is drawn in, bubbles appear in the viewing window. This is exactly what the water well prevents, by sealing the section with a liquid barrier that keeps the process stable, with the water level controlled by the second valve. To measure how much the tubing is stretched, we use the draw-down ratio, or DDR. The draw-down ratio is simply the die diameter divided by the final tube diameter. For example, if the die opening is 1/4 inch and the finished tube measures 1/8 inch, the draw-down ratio is 2. But for tubing, the more accurate formula looks at cross-sectional area. DDR equals die inside diameter squared minus mandrel outside diameter squared, all divided by the final tube's outside diameter squared minus its inside diameter squared. In other words, it's the ratio of the melt area at the die to the wall area of the finished tube. The puller controls this ratio by regulating line speed. Why does this matter? If DDR is too high, the tube can thin out and even retract, and break the spool after it's made as stresses are released. Too low, and surface finish and dimensional control suffer. For clear, flexible PVC tubing, DDR usually falls about 1.5 and 3, but always check with your supplier for the recommended range. Beyond tooling, process settings play a big role in tubing quality. The temperature profile along the barrel determines how well the PVC melts and flows. If it's too low, the surface can appear dull or rough. Raising temperatures can produce a smoother, glossier finish, but if they're too high, the material can burn. Here you can see the difference temperature makes. On the left is a tube with defects, while on the right is the result after raising barrel temperatures by about 10 to 20 degrees Fahrenheit across different zones. Equally important is screw design, which directly affects melt quality and consistency. Line speed and extruder RPM work together to control output. Faster speeds stretch the tubing more, while slower speeds give thicker walls and greater stability. Balancing temperature, speed, and RPM is what turns the same material into either scrap or a perfect, consistent tube. In this run, the tolerances were held to plus or minus 0.005 of an inch, with the goal of reaching a CPK above 1.3 for consistent quality. That's the process of making clear PVC tubing from tooling and settings to final product. Let us know if you're interested in a more hands-on video. Check out our video, How to String a Small Plastic Extrusion Line. If you found this helpful, don't forget to like and subscribe for more. Future videos will cover cooling tanks, extruders, and other downstream equipment.